Assalamu alaikum and welcome to this session for your Human Growth and Development course. We're going to be taking the second week of development today. We've already done everything up until the first week. And just so that you know, there's going to be a few new terms and a few new concepts that are going to come up in this lecture. And just to make them clear, I'm going to try and go a little slower, and I'm going to go, back and forth between the pictures and the text just to hopefully help you grasp the concepts easier. Okay, easily. So let's get started. So the second week of development comprises all the events that happened from day 8 until day 14. So basically anything from ovulation until day 7 is considered the first week, and then between day 8 and day 14 we consider that the second week. Now the easy thing or the trick to remembering the second week is that you just need to remember it as the week of twos, meaning that there's always going to be 2 of everything. If there's a layer of cells, it's going to split into 2. If there's a cavity, it's going to split into 2. If there's, cavities appearing out of nowhere, there's going to be 2 of them. Okay, so there's always going to be 2 of everything. The major event of this stage of development is establishment of the maternal-fetal communication, which is a connection between the maternal blood and the developing embryo. So the thing to keep in mind is that while the embryo is developing, there is a very high rate of cell division happening. There is a lot of different processes and things that are appearing and things that are disappearing, and things that are folding and things that are just growing and getting bigger. So obviously they're going to need a lot of nutritional support. They're going to need a lot of metabolic support as well. So the best and ideal way for this to happen is for there to be a communication, direct connection between the embryo and the maternal blood. And obviously the earlier this is established, then obviously the better the embryo is going to develop. So this is the main thing that happens during the second week, is establishment of the maternal-fetal communication. Okay, so by the end of the first week, this is what the developing embryo looks like. Now, if you guys remember, I stopped you last time at the stage where it became a morula, which was just basically a mass of 16 cells packed together. Now, going back to the concept of the fact that the developing embryo has a high metabolic requirement, okay, what happens is a cavity appears within the developing embryo, okay, similar to the cavity that appeared in the developing follicle, if you guys remember with the menstrual cycle. Okay, the idea is that as the cells are getting larger and dividing even more, okay, their metabolic requirements cannot just be sustained by the cells themselves. They need some extra support. So this support comes in the form of fluid that is filled with nutrients and will help with the growth process. So the appearance of this cavity within the developing embryo actually ends up pushing the cells to different sides, such that a mass of cells will kind of be pushed together at one side, and then the rest of them will form an external layer surrounding the outside of the blastocyst or the developing embryo. Okay, so this outer layer is called the trophoblast, or sometimes we refer to it as the outer cell mass. This mass of cells that is packed together is referred to as the inner cell mass, and it is also referred to as the embryoblast. So by the end of the first week, cell division and changes have caused separation of 2 cell masses, the outer cell mass, which is the trophoblast, and the inner cell mass, which is the embryoblast. Okay, so again, week of 2s. So the blastocyst, which is the whole structure, so basically the blastocyst is the stage that is after the morula. Once the cavity appears and is divided into 2 cell masses, we call it a blastocyst. The blastocyst will embed into the endometrial lining. So while it's being pushed into the endometrium and the whole implantation process is being completed, the trophoblast, which was the outer cell mass, will divide into 2 layers. So again, week of 2s, which is why I've put it in bold and underlined it for you. Okay, so it's going to divide into 2 layers, and we're going to call those the outer syncytial trophoblast and the inner layer, which is the cytotrophoblast. At the same time, the inner cell mass is divided into 2 layers as well. You've got a layer at the bottom, which is called the hypoblast, and then you've got a layer at the top, which we call the epiblast. All right, so let's just look at that in a picture. Okay, so this is the outer cell mass, and this is the inner cell mass. And you can clearly see that they have now been divided into 2 parts. The outer cell mass is now considered 2 layers. One of them is the layer that's in dark green on the outside here, and this is called the syncytial trophoblast. And then you've got the inner layer here, which is in light green, but we're still in the outer cell mass right now. Okay, this inner cell layer in green, or the lower cell layer, okay, this is called the cytotrophoblast. All right, but the inner cell mass, you can clearly see, is now divided into 2 as well. You've got this lower layer here, which is in yellow. That's called the hypoblast. And then you've got this upper cell layer, which is in blue, and you can clearly see how the cells are a little bit larger. This is called the epiblast. Now, once it reaches this stage where it's divided into 2 layers, I don't call it inner cell mass anymore. Okay, I now refer to it as the bilaminar germ disc. Okay, bilaminar, meaning that it has 2 layers. Okay, and germ disc referring to the fact that these are the original cells that will then develop to give me the more sorry, that will then end up giving me more cells that will then become the embryo. Okay, so it's called the bilaminar germ disc. So just a quick recap. I've got the outer syncytial trophoblast, I've got the inner cytotrophoblast, and I've got the bilaminar germ disc sorry, made of the epiblast and the hypoblast. So the thing to keep in mind is that eventually the outer cell mass becomes the placenta. Okay, and if you guys remember at the very beginning, I told you that because of all the cell division and growth and increase in size that's happening in the embryo, it's going to have a high metabolic requirement, and it's going to have a lot of requirements in terms of nutrition and getting rid of waste products and providing oxygen. Okay, so the way that this happens is through the formation of the placenta and a communication or a direct communication between the fetus and the mother. So where does that come from? That comes from the outer cell mass. So that's the importance of the outer cell mass. The inner cell mass will develop into the baby. Okay, so that's why the morula had to divide into 2 layers. One, to maintain or establish a communication with the maternal blood, and the other one to become the actual baby. Okay, so let's look at the syncytial trophoblast, which, if you guys remember, was the outermost layer, which was a dark green color. Okay, now while it's embedding and implanting into the endometrium even further. So it doesn't just stay at the very end. It actually goes deep into the endometrium. The two things that are happening to the syncytial trophoblast are that number one, it increases in size, so it starts to get larger. And number two, it develops cavities, which are called lacunae, or lacunar spaces, that initially start off as separate spaces, but fuse together to form something called the lacunar network. Okay, so I'm going to stop for a second and let you just kind of think about what would be the importance of these lacunar spaces. So the lacunae are important because they reach and fuse with the maternal capillaries. This allows maternal blood to flow through them, thus establishing the contact between the mother's circulation and the growing embryo. So remember I said the outer cell mass is going to become the placenta, and we're going to see later on how the placenta is actually basically the organ that allows the mother's blood to flow in and then communicate with the baby's blood. It carries things to the baby, it takes things from the baby's body. So that is how it is initially formed. Okay, so if you're looking here, this is the syncytial trophoblast outside here. You can clearly see how it's starting to develop spaces, okay, which are the lacunar spaces. And these are the maternal blood vessels in the endometrium, okay? And remember, we have progesterone, okay, which means that these blood vessels are enlarged, okay? And we're going to see later on how eventually these spaces and blood vessels fuse together in a way that this blood ends up flowing inside these spaces. Now, in the meantime, there are also changes happening in the inner cell mass. So just because there are changes happening in the outer cell mass, it doesn't mean that the inner cell mass is just kind of sitting there and thinking, okay, well, I'll wait for you to finish. No. All of these things and all of these changes are happening simultaneously. It's all going on at the same time. So the changes that are happening in the inner cell mass is, number one, you have a cavity appearing between the epiblasts, so remember that was the upper layer of the germ disk, and the cytotrophoblast. And this cavity is called the amnion, or we can refer to it as the amniotic cavity. Cells from the hypoblast will end up lining the cytotrophoblast on the inside and surround a cavity called the primitive yolk sac. And again, this is part of the whole week of twos rule, okay, because now I have two cavities. The primitive yolk sac is also referred to as the extracoelomic cavity. So it's got two names. You can either call it the primitive yolk sac or you can call it the extracoelomic cavity. So let's just take a look at that. Okay, so we're done with the syncytial trophoblast and all the lacunar spaces. You don't need to focus on that here. But let's just take a look at what's going on down here. Okay, so this is the bilaminar germ disk. You've got the epiblast, you've got the hypoblast. Okay, and this is the cytotrophoblast over here. So notice how you have a cavity sort of appearing between the epiblast and the cytotrophoblast. Okay. This cavity up here is called the amniotic cavity or the amnion. Okay? Now, this cavity down here, if you guys remember in the very first picture that I showed you where I showed you the appearance at the end of the first week, okay, this cell mass was originally up here, so the amnion wasn't around. Okay, and this was called the blastocyst cavity. Alright? But because the bilaminar germ disk kind of moved down a little bit with the appearance of this new cavity here, and of course with all the structural changes that are happening, I can't call this the blastocyst cavity anymore, okay, but I'm going to call it the primitive yolk sac, okay, or we can call it the exocoelomic cavity. And this yellow layer here is the line of cells that comes from the hypoblast that lines the primitive yolk sac and the cytotrophoblast on the inside. So these are my two cavities. The amnion above the epiblast, between the epiblast and the cytotrophoblast, and the primitive yolk sac, which is underneath the hypoblast and inside the cytotrophoblast. Excuse me. So once the uteroplacental circulation, which is basically the blood flow between the uterus and the developing placenta, once that circulation has begun, a new mass of cells appears between the cytotrophoblast and the primitive yolk sac. Okay, now remember how I told you with development, and specifically here we're going to have a lot of new things that just kind of suddenly pop up out of nowhere. So the thing to understand is that embryology is one of the fields that is still under research, and one of the patterns of embryology, or generally in development, is that you can have something developing a certain way and then suddenly a mass of cells appears somewhere, or a cavity appears somewhere, or a streak or a line appears somewhere. So things just suddenly show up. All right. So one of the fields of research is that they try to figure out where these things come from. So this is one of those situations where a mass of cells just appears. And again, where these cells come from is an area of debate, because some people think that they come from the hypoblast, other people think that they come from the cytotrophoblast, so this is still an area of research. Okay, so this is again the developing embryo. Okay, and let's just quickly review what we're looking at here, so you guys aren't lost. Okay, so what was this green layer out here? Okay, good. This is the syncytial trophoblast. All right. And what are these spaces? Okay, good. These are the lacunae, or the lacunar network spaces. Okay. And you can see here how the blood from the maternal blood vessels is kind of connecting and communicating with these lacunar spaces, so they're all filled with maternal blood. Okay, what was this layer here? The one that's in light blue. Okay, good. This is the cytotrophoblast. Okay, what was this thing called? Okay, good. This is the bilaminar germ disc made of the epiblast and hypoblast. Good. And we have two cavities, the amniotic cavity and the primary or primitive yolk sac. Okay. Now, if you notice with the original picture, the primary yolk sac and cytotrophoblast were kind of stuck on each other, with the exception of this layer of cells here. But now there's kind of a gap or a space between them that is filled with this red mass of cells here. Okay? And like I said, they just kind of show up out of nowhere. So this mass of cells that appears between the cytotrophoblast and the primitive yolk sac, and if you notice, it kind of shows up at the top here as well. Okay? This is called the extraembryonic mesoderm. Okay, so the extraembryonic mesoderm is a mass of cells that appears between the cytotrophoblast and the primitive yolk sac. So this mass of cells, like I said, is called the extraembryonic mesoderm. Now what happens with the extraembryonic mesoderm is that with time, a large cavity will appear in this layer, dividing it into two. Okay? A layer of cells will line the cytotrophoblast, and a layer of cells will line the primitive yolk sac and the bilaminar germ disc. This cavity that appears in the extraembryonic mesoderm is called the chorionic cavity. So here we go. Okay. If you remember with the first picture, this was one single mass of red cells with the exception of the cavities that had started appearing up here and up here. Okay? Now there are multiple cavities all throughout the extraembryonic mesoderm, and eventually what's going to happen is that these spaces are going to fuse together to form one large cavity. And then that cavity is just going to keep getting bigger and bigger and bigger. All right? The cavity that forms is called the chorionic cavity. Now, I want you to notice how up here, the layer of extraembryonic mesoderm that's just above the bilaminar germ disc here, okay, does not have a cavity in it. So the cavities are all around here, but there's no cavity that appears in this region here. Okay, so I want you guys to remember that for later. Okay, so as the chorionic cavity continues to enlarge, what will happen is that a segment of the primitive yolk sac will be pinched off. So think of it this way. The primitive yolk sac now has a cavity that is appearing outside it, and that cavity is getting bigger. So as soon as the cavity on the outside keeps getting bigger and bigger, what's going to happen to the primitive yolk sac? It's going to get smaller and smaller because it's being pushed from the outside. Okay? And because it's being pushed from the outside, a segment of it will be pinched off, and the size of the primitive yolk sac will get smaller. Once it becomes smaller, I don't call it the primitive yolk sac anymore. I refer to it as the secondary yolk sac. And just for you guys to get an idea of what that looks like, this is the appearance. Okay? This is the enlarged chorionic cavity. It pushed the primitive yolk sac from the outside to make it smaller. This is the part of the primitive yolk sac that got pinched off. And now I have to call this the secondary yolk sac. Alright? And the part of the primary yolk sac that got pinched off is called the exocoelomic cyst. And this large cavity on the outside here is now the chorionic cavity. Okay? Now, remember I said that part of the extraembryonic mesoderm remains above the bilaminar germ disc without developing a cavity. Okay, so that's this region here. And you can see how part of the extraembryonic mesoderm lines the cytotrophoblast on the inside, and part of it will line the developing bilaminar germ disc and the yolk sac. Okay? Now remember I told you you're going to need this for later. The cells of the extraembryonic mesoderm that remain at the pole of the bilaminar germ disc connect it to the cytotrophoblast, and this is called the connecting stalk. The connecting stalk will eventually become the umbilical cord. Okay, so here you can see that this mass of extraembryonic mesoderm is left over, but if I follow it, I can see how it is connected to the cytotrophoblast, and if I follow it back, it's connected to the bilaminar germ disc. So that is how there is a communication between the developing germ disc and the outer cell mass, which is now becoming the primitive or developing placenta. Okay, and you can see here how the lacunar spaces are now just filled with maternal blood. Okay, and they are connected through the connecting stalk. Alright, so in summary, the events of the second week are as follows. The blastocyst becomes completely embedded in the endometrial wall, so implantation is complete. So implantation starts in the first week and is completed in the second week. Changes are happening in the outer cell mass in order to establish the uteroplacental circulation. Cavities appear in the embryo, and these are essential to development in later stages. They're also important for nutrition. And at this point, the developing embryo is made of two layers, which are the epiblast and the hypoblast, and it is referred to as the bilaminar germ disc. Okay, so I know that was a lot of information, okay, but if you take it in a stepwise process, the second week is not that complicated. I know there's a lot of names that you guys are going to have to remember as well, but just take it step by step, okay? As long as you go in chronological order, then it should be easy for you guys to remember the events of the second week. And as always, I'm going to leave you with a positive quote. I know you guys are under a lot of pressure right now. I know that there is so much work that you guys need to do, you know, especially with everything going on in the world right now and how, you know, you guys are worried about passing exams and everything. But just remember that the day that you plant the seed is not the day you eat the fruit. So you guys have to put in the work now. But I promise you, you will be rewarded for all of your efforts. So keep the faith, stay positive, work hard, and you will achieve everything you dream of achieving. And thank you so much for joining me for this session. I hope it was useful and that the concepts are clear to you. And I will see you guys next time.